Hello everyone, let's solve some Leetcode today. So today we have Leetcode 69, that is square root of x. In this problem we have been given an integer x and we have to figure out the square root of x rounded down to the nearest integer. It means that we cannot return any decimal point values. We have to return an integer which is closest to its square root. Also the output or the answer should be non-negative. Simple. Now you must not use any built-in exponent function or operator for this. We have to figure out the logic by ourselves. We cannot use the functions like pow or this kind of operator in Python because we have to figure out the logic by ourselves. Now there are many ways to actually solve this problem, but the one we are going to look at is binary search. Yes, we can solve this problem with the help of binary search, and that will make the time complexity very low. So in binary, we know that we have to divide the search space based on a condition. We will have an L pointer equals to 0 in this case, I believe. Then we will have a right R pointer, and it will be equal to what? It will be equal to x. So we will consider all the numbers from 0 to given integer x, and we will figure out which one is actually square root of x. So we will figure out the mid like this: x plus 0 divided by 2. And now we will check if mid is actually equals to x, simply return mid. If mid is greater than x, simply say r is equals to mid. That means we are shifting the right pointer to mid. Otherwise the mid will be less than x. It means we can actually shift the L pointer to mid plus 1. So we have L pointer, we have R pointer, we can also calculate the mid, and we have three conditions that tell us how to actually move the left and right pointers to figure out our answer. Of course, these are mid square, these are not just mid, so mid square and then mid square. So we will just multiply mid by mid. Now let us try to understand with the help of an example. Here we have x equal to 8, and here we have written a binary search with the help of the above condition that we saw. So we are starting with L equal to 0, R equal to 8, mid equal to 0. Then while L is actually less than R, we will keep running this binary search algorithm. So first of all, we are trying to calculate a mid. In the first case, the mid will be equal to 0 plus 8 divided by 2 is equals to 4. Right now the mid is 4. Now we are calculating the square of mid. So mid multiplied by mid is going to give a square, which is going to be 16 right now. And now we are checking, is 16 equal to x? Well, of course it is not equal to 8, so we are not going to do anything. Is 16 less than x? No, it is not less than x. Then at the end of the day it is greater than x, so we are simply shifting the r to mid. So now r is equals to, and mid is also equal to 4. Now we will try to calculate mid again. So mid will be equal to now 0 plus 4 divided by 2 is equals to 2. The square of 2 is going to be 4. And now we will check, is 4 equal to 8? It is not equal to 8, so we are not going to do anything here. Is it less than 8? Yes, 4 is less than 8, so we will shift the L to mid plus 1. So L will actually become mid plus 1, that is 2 plus 1, that is 3. So L will be now 3, and mid is also changed now, so mid will actually become 2. Now let's try to calculate mid again. So mid will now become 3 plus 4 divided by 2 is equals to 7 divided by 2 is equals to 3. The integer division will result 3. And the square is now 3 into 3 is equals to 9. Now we can check, is this square is actually equal to 8? It is not equal to 8, so we are not going to return mid. Is this 9 less than x? It is not less than x, so we are not going to shift the L pointer. Is it greater than x? Yes, it is greater than x, so we will shift the right pointer to mid. So the right will become mid, that is 3. And the mid is now actually 3 2, so it will become 3. And at this point we can see that L and R are actually equal, so L is not less than R anymore, so this particular binary search will stop. Now at this point the mid is actually equal to 3, but we know that the square of 3 is actually going to be 9, which is greater than 8, and we have to return the nearest integer that is equal to the square root of 8. So 1 less than 3 is 2, square of 2 is 4. It is also not equal to 8, but 2 is the nearest element. But then you can also say that 3 is also nearest element, but we want the square of the nearest element to be less than or equal to the given x. That's why we are taking 2. What this means is that if we ever found a mid that is actually the square root, we will simply return from here. But if this entire binary search runs, it means that we are at a mid which is 1 greater than the answer that we want. So we will simply return mid minus 1. This is going to be the case every time. Now there is a situation where we might actually get mid equals to 0. If this ever happens, if mid ever becomes 0, we cannot do this mid minus 1 because it will actually return to minus 1. And non-negative numbers are restricted. So in this case, if mid ever becomes 0, we will simply return mid plus 1. So these are the edge cases that we will need to consider in our solution. Mid will actually become 0 in cases where you want to try and find out the square root of 1. So for 1, the L will be equal to 0, the R will be equal to 1, and the mid will actually end up becoming 0 plus 1 divided by 2, that is 1 divided by 2, that is going to be 0. So here the mid is actually becoming 0, but we know that the square root of 1 is actually 1 itself. So that's why this is the edge case that you have to keep in mind. So now let us go through the code itself. Here we have L is equals to 0, R is equals to X, and we have mid initialized as 1. Now we are starting while loop for binary search. So while L is less than R, here we are calculating the mid. Then we are having these three conditions that will help us determine what to do with the L pointer and R pointer. After this, what we are doing is we are checking the square of mid. So whatever mid we got, if its square is actually greater than X, we will simply return mid minus 1. Just like we saw with the case of 3, the square of 3 is actually greater than 8, it is 9. That's why we had to actually decrement it by 1 to return 2. Now in case the square of mid is less than X, we can simply return mid. Even there we have a condition. So we will return mid only if the mid is not equal to 0. If the mid is equal to 0, do not return mid. You should return mid plus 1. So here we are actually checking that edge case where we might try to find the square root of 1 and we will end up with a mid equal to 0. So at that time we will have to return mid plus 1. Otherwise we can simply return mid. Now we will run it and try to see what happens. So yeah, it works in 4 milliseconds and beats 41.67% of the solution. It's a pretty efficient solution. Since we are using the binary search, the time complexity is going to be order of log x. X is basically representing the search space. So x you can also call it n. And the space complexity is going to be constant because we are only initializing L, R and mid. And these three take constant space for each iteration and we are not creating any array or hash set or hash map that will take order of n space. So that's why we have a constant space solution. So yeah, like the video, subscribe the channel. If you have some kind of question that you would like me to target or you have some kind of topic that you would like me to talk about, just let me know in the comments. Now we will meet in the next video. Till then, bye.